In this video, I want to talk to you guys about normal distributions and standard deviation and how we can use that to find probabilities and percentages of particular events that might happen. Now, the normal curve is going to always be bell-shaped, it's always going to be symmetric, and it's always going to have one peak. And that peak is going to be where the mean occurs. Now, I don't have very good art skills, so this doesn't look very symmetric. But imagine that I had a steady hand. We have a bell curve. It's symmetric, which means if I folded it right here, it's going to line up on either side like a mirror image. Okay, now the mean is always going to be in the center. So here's my X bar. Now there's a nice little rule to help us figure out some basic probabilities and some basic percentages. Okay, it's called the 68, 95, 99.7 rule. And what that means is if I had a mean, and this was a normal distribution, and I was within one standard deviation from the mean, so either this way or this way, this one is called -1 for the standard deviation just because I'm to the left of X versus to the right. It still means I'm one standard deviation away. It just means I'm one standard deviation to the left is what that minus means. So from here to here is 2 standard deviations to the left because this is minus. From here to here, this is 2 standard deviations coming from the right. Okay, so the 68, 95, 99.7 rule says that if I'm within one standard deviation, so from here to here, that in there lies 68% of the data. If I'm within 2 standard deviations from the mean, so that's this right here, from here to here, 2 standard deviations, from here to here, that's 95% of the data, approximately. And then if I go out to 3 standard deviations in either direction, that would be 99.7% of the data would fall from here to here. Now, how can that help me calculate percentages or probabilities? Here's an example. Let's say I wanted to figure out information about the weight of all adult men. Now, I don't have contact with all adult men in the US, so I would have to take a sample. And let's say I took a sample of 75 men. When I took the average of that sample of their weight, I would get 163.72 for this particular sample, and I would have a standard deviation of 30.73. That means, on average, a man would be a data value would be within 30 pounds. This is in pounds. Sorry, I forgot to label that. 30 pounds of the mean. So, using our 68, 95, 99.7 rule, if I go, since each standard deviation is 30.73 and the mean is 163.72, this 163.72, the mean goes in the center. One standard deviation to the right means I would take 163.72 and add one standard deviation, which is 30.73. If I want to go out 2 standard deviations, I add another 30.73. If I want to go out 3 standard deviations, I add another 30.73 pounds. Going in the other direction, if I want to find one standard deviation to the left, I subtract 30.73 from the 163.72, etc. So I could say, once I figure out all my standard deviations, that I know if I look at the middle value right here between one standard deviation to the left and to the right, I know that 68% of my data falls between these 2 values, here and here. So I can say approximately 68% of men are between 132.99 pounds and 194.45 pounds. Going out one more standard deviation, if I go out 2 standard deviations in either direction, I can say that that encompasses about 95% of men. So I can say about 95% of men are between 102.26, that's 2 standard deviations out this way, and 225.18 pounds, that's 2 standard deviations this way. So 95% of men fall between these two values for their weight. And then going out one more time from here to here, I can say approximately 99.7% of men have a weight between 71.53 pounds and 255.91 pounds. Now, what if I just wanted to find out how many men are in this upper half here, this extreme case here? Well, if I know from here to here is 95% of the data, then I know the tails total must consist of 5% of the data. If 95% of the data is from here to here, then this and this must be total 5%. Because the normal curve is symmetric, I know that each tail has to contain the same amount. So from here over needs to be 2.5%, and from here over needs to be 2.5%. So I know that approximately 2.5% of men are more than 225.18 pounds. And looking at it from a different perspective, also, if I want to figure out how many men weigh less than 132.99 pounds, that's right here. I want to figure out how many men lie from here to here less than. So if I look from here to here, that's 68% of my data lies between here and here. That means from here to here has to be a total of 32, which means 16 on this side, 16% on this side. So I know from here over, it's got to be 16% of men. So I know approximately 16% of men weigh less than 132.99. And that's how we can use the 68, 95, 99.7 rule to approximate some probabilities and some percentages.